You are probably most familiar with tidal forces from the tides in the ocean, from which they derive their name. Because of this, you might reasonably think that tidal forces are rather mundane. And while that is true for certain objects, including Earth, on others, tidal forces are hugely important. Occasionally they are the causes of the defining physical traits of an entire planetoid, usually a moon. An example of this that I've mentioned in a previous video is the icy Saturnian moon Enceladus. Due to where it orbits relative to Saturn and its other moons, the core of the moon is stretched and squeezed. This causes heating through friction, and this heat has melted the ice near the core of Enceladus, creating an underground ocean. An example of this that is closer to home, and as a result much better studied, is Phobos, the larger of the two moons of Mars. Although it is twice the size of Mars's other moon, Deimos, Phobos is still tiny by astronomical standards. At just 12 kilometers wide, it is more comparable to surface features on Earth than to our moon. To nail down this point, here is a roughly to scale comparison of Phobos to the peak of Mount Everest. The surface of Phobos is covered in streaks, small canyons and trenches that extend the entire way around the surface of the moon. At a glance, they seem to radiate from the massive crater on Phobos, called Stickney Crater. This is what astronomers originally thought, but as measurements became ever more precise, it was realized that the streaks radiate not from the center of the crater, but from the leading point of Phobos. A leading point is the part of an object that is furthest ahead in the orbit. Basically, if you drew a gigantic circle to show where the orbit of an object is, wherever that circle intersects with the surface of the object is either the leading point or the trailing point. Since an orbit is a form of movement, there will always be a forward and a backward. The leading point is simply whichever of the intersection points is forward. Phobos' rotation is locked such that it matches its orbit exactly, the same way that our moon is locked with its orbit, such that one side always faces Earth. Because of this locked orbit, the leading point of Phobos is always the exact same spot on its surface. The reason that it looks like the streaks radiate from Stickney Crater is that the leading point of Phobos happens to be inside Stickney Crater. Since the streaks don't radiate from the center of Stickney Crater, they can't be a result of the collision that created it. Instead, as evidenced by the location of the leading point, they are the result of tidal forces. Moons as small as Phobos usually aren't affected by tidal forces, but Phobos has two things that make it unusually susceptible to them. Number one is that Phobos is extremely close to Mars. The average distance between them is only 9,000 kilometers, which is 1/42nd the distance between Earth and its moon. Phobos is so close to Mars that when seen from the surface, it is visibly smaller at the horizon than when directly overhead, since it is so much farther away sideways. Similarly, Phobos is impossible to see from the poles of Mars. Number two is that even for its size, Phobos is extremely light. Phobos is so light that it probably isn't a solid piece of rock. Rather, it is likely a rubble pile with a layer of dust on top, making it look more cohesive than it really is. At a basic level, tidal forces are caused by one part of an object being farther away from the source of gravity than another, resulting in a stretching effect. The closer you are to the source of gravity, the greater the difference in forces, and the greater the stretching effect. If the object rotates relative to the stretching effect, like how Earth does rotate at a different speed than the moon orbits, even though the moon rotates at a speed that matches its orbit, then this stretching effect moves across the surface of the object. In Earth's case, this causes bulges in the oceans that move across the surface as Earth rotates under the moon, the tides. Mars has tides too, although the lack of oceans and comparatively minuscule moons make the tides there much, much smaller. However, since Phobos is so close to Mars, the difference in gravitational pull it feels is relatively large. Like how Mars has tides from Phobos and Earth from the moon, Phobos has tides from Mars. Since Phobos is locked towards its orbit around Mars, its tides don't move across its surface like how they do on Earth or Mars. Instead, the slight variations in the distance of Phobos' orbit cause the gravitational difference to vary ever so slightly, creating a very small tidal force. Since Phobos is so loose, even the tiny tidal force it feels has an easy time moving material inside the moon. This shifting of material, which can be thought of as a miniature version of plate tectonics, is what causes the streaks across the surface of Phobos, which are almost comparable to fault lines. There is another hidden effect that Phobos' tidal forces have. Like how Earth's tides cause friction on the ocean floor, which slows down Earth's rotation, dumping the momentum into the moon's orbit instead, Mars's tides also move momentum around, but in a different direction. Since gravitational force increases as an object gets closer to the source, and orbital velocity increases with gravitational force, the speed of an object close to its parent body is very high. Phobos orbits so close to Mars that it orbits Mars faster than Mars rotates. This is important because rather than Earth's moon, which orbits slower than the Earth rotates and is essentially pulling Earth's rotation back, slowing it down to increase its own orbital velocity, Phobos is pulling Mars's rotation ahead with it, reducing its own orbital velocity in the process. Phobos is very slowly falling towards Mars, at a rate of 2 centimeters per year. Since Phobos is so small, the tidal forces that cause the streaks won't break it apart in time to prevent it from crashing into the surface of Mars. In case you had the same thought I did, Phobos is about the same size as the asteroid that killed the dinosaurs on Earth.